Okay, we're on problem 13 here. And in problem 13, we want to find an equation for a line containing the point -2, 4, and is parallel to the line -1/2 x minus 7. Write your answer in slope-intercept form. Okay, so in this problem, we have a point that's on some line that we got to find, and it's got to be parallel to this line that we're given. So the first thing that I notice here is that the slope of the line that I'm given is -1/2. Okay, so any line that's got to be parallel to this one here has to also have a slope of -1/2. Okay, so we know the slope is -1/2, and we know a point on this line. Okay, so let's use the point slope equation next. We got y minus y1 is 4 equals the slope, that's -1/2, times x minus x1 is -2. X minus a -2, this one is x plus 2. Okay, they want us to write the answer in slope-intercept form, so I got to solve for y. I got to write the answer in the form y equals mx plus b. Y minus 4 is equal to -1/2 x minus 1. And then when I add 4 to both sides, y is equal to -1/2 x plus 3. Okay, now I know that these two lines are parallel, right, because they have the same slope, -1/2. I also know that they're different lines because they're going to cross through the y-axis at different spots. Okay. Problem 14 is a similar problem here. It says to find an equation for a line containing the point 9, 4 and is perpendicular to the line y equals 3x minus 7. Write your answer in slope-intercept form. Okay, so in this problem, I've got a point that's on this line that I got to find, and it's got to be perpendicular to this line that I'm given. Okay, this line that I'm given has a slope of 3, so any line that's going to be perpendicular to this one has to have a slope that's the negative reciprocal of 3. Okay, so that'd be -1/3. Because if I take 3 times -1/3, I get -1. And by definition, that's what it means to be a negative reciprocal. So I got to multiply these two numbers together, and I get -1. Okay, so the slope is -1/3. We know a point on the line is 9, 4. So let's use the point slope equation next. Y minus y1 is 4 equals the slope, that's -1/3, times x minus x1 is 9. Okay, and I got to write my answer in the form y equals mx plus b. So let's solve for y with this. If I distribute the -1/3, I got -1/3 x plus 3 on the right. Okay, and then when I add 4, y is equal to -1/3 x plus 7. That'd be the answer. Okay, and I know that these two lines are perpendicular because the slopes are negative reciprocals. Okay, if I take 3 times -1/3, I get -1. Now, sometimes I see a mistake from students like they'll take the reciprocal, but not the negative reciprocal. Okay, so like they'll call it 1/3, and they'll give me a wrong answer. Okay, make sure that you got the negative reciprocal. Okay, now when we look at these two examples here, problems 13 and 14, it's the same thing. The only thing I'm doing is I got to get the slope correct. Okay, so parallel lines have the same slope, and perpendicular lines have slopes that are negative reciprocals of each other. After I have identified the slope, then I'm using the point slope equation next. Okay. Let's try problem 15. So in problem 15, it says that a person is driving a car on a straight road. The graph shows the distance y in miles that the individual is from home after X hours. Okay, so after 1 hour has gone by, they're 50 miles from home. After 3 hours have gone by, they're 110 miles from home. Okay, In part A, we want to find the slope-intercept form of this line here. Okay, well, the first thing I have to know is the slope. So I got 2 points on this line, right? And a change in y over change in x. So x1 is 1, y1 is 50, x2 is 3, y2 is 110. And when I plug in these numbers here, I get y2 minus y1 over x2 minus x1. That's going to be 110 minus 50 is the difference in the y values, divided by the difference in the x values. That'd be 3 minus 1. 3 minus 1 is 2. 110 minus 50 is 60. 60 divided by 2 is 30. Okay, so the slope of this line would be 30. And I also know a point on the line. I know 2 points on the line, but I could use the point-slope equation next. Okay, and let's just use this point here. So the slope is 30, right? So I got y minus y1 is 50 equals 30 times x minus x1 is 1. Okay, and they want us to find the slope-intercept form of the line. So I need to solve for y. And I mentioned this before, but anytime you work with lines, always give the answer in the slope-intercept form. Okay, it's like you're not done with the problem yet until you're in the form y equals mx plus b. So if I solve this equation here for y, let's distribute 30 on the right. I got 30x minus 30. And then when I add 50 to both sides, y equals 30x plus 20. Okay. Part B, it says, how fast is the car driving? Well, let's see. So x is the number of hours, and y is the distance. Okay. So so this car would be going 30 miles per hour. Is the number in front of x. So 30 miles per hour, that'd be the answer. Okay. Now, part C, how far was the individual from home initially? So x is the number of hours, and y is the distance. Okay, so it looks like if x is 0, okay, after 0 hours have gone by, the individual would have been 20 miles from home. Okay, so 20 miles would be the answer. Like to me, it is just asking for, what's the y-intercept? Okay, or the b value would be 20. In part D, it says, how far was the individual from home after 3 hours and 15 minutes? Okay, so 3 hours and 15 minutes, that's a fourth of an hour. Okay, so x is the number of hours, right? All I need to do here is I need to replace x with 3.25 and then simplify that. Okay, so I got 30 times 3.25 plus 20. And when I go to the calculator next and simplify that, I should be getting 117.5 miles. Okay, so if I just check that real quick, I got 30 times 3.25 and then plus 20 gives me 117.5 miles. Okay, so that's problem 15. Problem 16 is where it says that a banquet hall hosts wedding receptions. There is a charge to rent the hall in addition to a per-person charge for the meal. Christy has 120 guests at her wedding and paid a total of $4,100. Caitlin had 175 guests at her wedding and paid a total of $5,750. Okay, so part A, they want us to find a linear equation for the total charge y where this is to host X guests. Okay, so let's see. The last two sentences in this information is really them telling me 2 points that are on the graph. Okay, this line. Okay, I need to find a linear equation so I can know I'm working with a line, right? The points 120, 4,100, and 175, 5,750 are 2 points on this line. Okay, we want to find the equation of the line, so get the slope, change in y over change in x. So 5,750 is y sub 2, minus y sub 1, that's 4,100, divided by x is, x sub 2 is 175, minus x sub 1 is 120. Okay, and when I simplify this here, 5,750 minus 4,100 is 1,650. And then 175 minus 120 is 55. When you take 1,650 divided by 55, you get 30. Okay, so the slope of this line here is going to be 30. Now, I need to use the point slope equation, right? Because I know a point on this line. Actually, I know 2 points on this line, so it's not going to matter which point I select. Looks like I'm selecting the first point here. Okay, now I get the same answer, you know, if I were to select the second point for x1 and y1. So let's use the point slope equation. I got y minus y1 is 4,100 equals the slope is 30 times x minus x1 is 120. Okay, and then I need to get that in slope-intercept form. So let's solve for y. When I distribute 30, I got 30x minus 3,600 on the right. And then when I add 4,100 to both sides, y is equal to 30x plus 500 would be the equation of this line here. Okay. In part B, it says, in your own words, explain what the slope of this equation represents. So the slope, that's the number in front of x, that's 30. Okay. X is the number of guests, and y is the cost that you're paying, right? So it looks like it's going to be $30 for each guest that you have at the wedding. Now they're not asking for it, but the y-intercept is 500, right? And so there's going to be a $500 charge just to get the banquet hall in the first place. Okay, and then once you paid the $500 to get the banquet hall, then it's going to be $30 for each person there. Okay. All right, we'll go ahead and stop the video right here, and I'll pick up with problem 17 in the next one.